Alright, so this problem, basically both the problems can be solved using just a sliding window technique. Here we are having nums and k, and we are asked to find every subarray of size k which is valid. By valid I mean the which is in consecutive order and sorted order. So this is 1 2 3, so it's in consecutive sorted order. This is in consecutive sorted order. This one is not, this one is not, and this one is not. So the ones that are not, I add answer, I mean add -1 to the answer. The one that are valid, I'll add the last element that I have. Alright, so this is the answer that we get. We can solve using sliding window technique. It will be of one n operation, and we can code it up and understand as we go. So I'll have a streak like I mentioned, which is initially 0. I'll have my vector of int answer. Uh, for the first element, I process it here itself. So if k is equal to 1, which means a single element is valid in itself. So I'll add answer here itself. That will be nums of 0. And at this point, I'll start from the first element because I've processed the 0th element already. Right, and this will be nothing but nums dot size. I'll check if nums of I is equal to nums of I minus 1 plus 1, isn't it? If the previous element added by 1 is equal to the current element, in that case it's valid, so I'll increase the streak, else I'll reset the streak to 0. Here I'll check if I is greater than equal to k minus 1, which means at this point I should start adding uh, you know the answer. I'll start populating the answer because at this point I have a window size of k. So at this point I'll check if streak is greater than equal to k minus 1. I'm doing k minus 1 because think of a scenario like this, right? uh, or probably something like this, right? This is not valid, but this is valid now, so this will be true, and this will be also true. So at this point I see that the streak is 2, but the window size is 3. So I should be checking for streak if it's greater than equal to k minus 1. So here streak was 2 is greater than equal to 3 minus 1. So essentially I'll be checking this, and at this point I'll put the answer. Else, if that is not the case, then I'll just copy this out. This will be nothing but -1. At this point I'll just show an answer. Space complexity will be O of n. Time complexity will be O of n, and space will be O of 1. Let's see if this works. This is the second problem, by the way, and the same will work for the first one as well. I was thinking something better here. I was thinking something binary search that I can apply. Probably we can, not too sure. And if we can, then probably that will be a more optimal solution, because that will be some log n factor. But I'm not too sure if we can. Alright, so these are the two problems, and thanks guys.